The new chapter of the syllabus is Heron's Formula. What is Heron's Formula? Before we get into the chapter called Heron's Formula, let's be brief with the introduction. Imagine we have discussed about many geometrical figures like the triangle, the rectangle, the square, the parallelogram, the trapezium, the rhombus, and etc. So like this, we have seen various geometrical figures whose areas were also identified. For example, for a triangle, we have identified that area of triangle is half into base into height. We have also discussed in the previous session about area of rectangle, which is length into width, and area of parallelogram, which is base into height. So like this, we have many geometrical figures whose areas and perimeters have been discussed in brief. So this session is about reintroducing the concept of areas and perimeters of various geometrical figures. Most importantly, with a three-sided closed figure in the planar region called triangle. Before this, let's try to revisit the concept of area and perimeter. So here we have there are two important things we discuss when it comes to a geometrical figure. So any geometrical figure we first identify in the planar region with two important concepts. One is the area and the other is the perimeter. So what is area and what is perimeter is what we're going to discuss in the session. Imagine I take a rectangular piece of plank or a box. So in this case, let's try to understand the difference between understanding area or visualizing area and the perimeter for this example model. So clearly I see that this is rectangular and this is the length and this is the width. So the dimensions of the rectangle, which is with length and width, we know that the area is the entire region covered by the rectangle. So for this disk, this entire thing makes out the area. So area for this rectangular plank would be length times width. Let's see now what is perimeter. So in order to understand perimeter, we see that firstly, what is the boundary for this plank? I have four different sides which covers the entire rectangular plank. 1, 2, 3 and 4. So imagine, say for example, if the ant starts from here and tries to move along this edge and then tries to move along this edge and this then moves along this edge, and the same ant now makes a journey from here to here, then we say that the journey made by the ant right from here unto all the four sides until it reaches its initial position is nothing but perimeter. So this clearly makes us understand that perimeter is the sum of all the boundaries, is the total length of the boundary is what is perimeter. The total space of the planar region is called area. So let's see in brief about the example of a wooden plank to understand area and perimeter in general terms. So area and perimeter. Area is defined as it is the region covered by the closed figure in the planar region. It is the region covered by the closed figure in the planar region. For example, I take the example of the rectangular plank as we have discussed. This would be nothing but the area. So this dotted region, which covers the entire closed solid four-sided figure, is nothing but called the area. So this represents the area. The dotted region is area. Now let's see what would be the perimeter understood in general terms. Perimeter, it is the total length of the boundary of the closed figure in the planar region. It's how we differentiate between area and perimeter. Perimeter is the total length of the boundary of the closed figure in the planar region. Let's take the same example of a rectangular plank as taken as the model. No doubt this is the area, but when it comes to the perimeter, we take the total length of the boundaries, this, and this. Say the length of this boundary is L1, the length of this boundary is L2, L4, then perimeter is sum of all the four lengths, L1 plus L2 plus L3 plus L4. Sum of all the lengths of the rectangular plank is nothing but the perimeter. The region covered by the closed figure, this whole region is called area, and the length of the boundaries is called perimeter. It's how we understand the difference between understanding the area and the perimeter for a closed figure in the planar region. Area and perimeter. So now that we have understood the difference between area and perimeter for a closed figure in the planar region, now let's see how we can apply the concept of understanding the area and perimeter for exclusively a three-sided closed figure called a triangle. This session is about discussing the area of the triangle three-sided closed figure. Area and perimeter of a triangle using Heron's formula. Imagine I have a triangle. Say for example, I have a triangle. And then I want to find, say this is A and B and C, and this is the region covered by the triangle, that is the area which I need to find. So here my question is, my investigation is about finding area of this dotted region, that is area of triangle. So let's see how we can find. Say for example, I only have the information of all three sides. This is a triangle whose side opposite to vertex A is A, whose side opposite to vertex B is B, and the side opposite to vertex C is C. Then we have Heron's formula, which we use to find area of triangle. So Heron's formula helps us in finding area of triangle if the three different sides of the triangle are given. If the sides of the triangle are given, we use Heron's formula. So let's see how the formula can be applied. Now we know that the perimeter of the triangle is, for this triangle, the perimeter of triangle ABC is A plus B plus C, because perimeter is the length of all the three boundaries. So perimeter of triangle ABC is A plus B plus C, sum of each of the sides. Now, the semi-perimeter of triangle ABC, which is denoted by S, is nothing but half of A plus B plus C. Is how we understand the semi-perimeter. We need to use the concept of semi-perimeter in finding the area of triangle ABC. So semi-perimeter of triangle ABC is S, which is half times A plus B plus C. So let's see how we can find area of triangle using Heron's formula. So area of triangle ABC by using Heron's formula is given by root of S into S minus A, S minus B, S minus C. That's how we get the Heron's formula. Root of S times S minus A, S minus B, S minus C. Heron's formula of this unit square is the area is what is called Heron's formula. If three sides of a triangle are given ABC, then we can find the area of the triangle using the semi-perimeter S, which is given by A plus B plus C by 2, and the formula for finding area of triangle ABC using Heron's formula is root of S into S minus A into S minus B into S minus C unit square. Area of triangle connected with Heron's formula. Now that we have discussed about Heron's formula, let's try to apply in one of the problem to find the area of the triangle using Heron's formula. This session is about applications of Heron's formula. Applications. Let's take an example problem to understand how Heron's formula is successful in finding area of the triangle. So for example, I have a triangle ABC in which I have the dimensions 40, 24 centimeters and 32 centimeters, or here it is 24 and here it is 32. Now this is the triangle for which I need to find the area. So let's see how we can find the area of the triangle. Find the area of the below triangle ABC. If the question says find the area of this triangle whose dimensions are given as 40 centimeter, 32 centimeter and 24 centimeter. So let's see how we can find the area using Heron's formula. So we know that the Heron's formula needs the semi-perimeter which we need to find. So let's see first what are the values of A, B and C from the triangle, and then find the area using the values of A, B, C. So first thing is to identify the values of A, B, C. The side A is opposite to vertex A, therefore from this I have A is 40 centimeter and my B is the side opposite to vertex B, which is 32, and C is the side opposite to vertex C, which is 24. So A, B, C are first identified. That implies when I have all the three sides, I can find the semi-perimeter S. So semi-perimeter S is given by the formula A plus B plus C by 2. Therefore, I have A plus B plus C, that is 40 plus 32 plus 24 by 2, which on further simplification gives us 48 centimeter. Therefore, I have my S, which is 48. Therefore, S equals 48 centimeters. So using A, B, C and S, I can find the area of triangle using Heron's formula. So let's see how we can apply Heron's formula. So let's get back to Heron's formula, which says that area of triangle ABC is given by root of S into S minus A into S minus B into S minus C. And with this formula, let's substitute each of S, A, B and C into the formula. So S is 48 and S minus A is 48 minus 40, S minus B into S minus C. So this on further simplification gives times 8 and 24 is what we get. So this on further multiplication gives 24, 16, 16, 24, which on multiplication gives 16 times 24, because root of this multiplies once to give this. So 16 4 64, 62 is 32, 38. Therefore, I get my area, which is 384 centimeters squared. So using Heron's formula, therefore, area of triangle ABC is 384 centimeter square. Heron's formula helps me in finding area of triangle whose dimensions are given. The sides are given. We can find area using Heron's formula. Applications of Heron's formula using the dimensions of triangle. Now that we have discussed about Heron's formula and its application in solving various scalene triangles, the areas of triangles whose dimensions are given, irrespective of the height. Let's see some special cases of the areas of triangles which can be found for different cases. Initially, to start with, equilateral triangle. Area of equilateral triangle. So what is area of equilateral triangle? We all know that equilateral triangle is a triangle whose all sides are equal. So this is equilateral if all the three sides are equal. That means if I take one of the side as A, even this would be A and this would also be A. So for a triangle which is equilateral with each sides being equal, area of this equilateral triangle is given by a specific formula. Is given by a specific formula. So let's see how we can find the basic formula out here. So using Heron's formula, we know that the area of triangle is using the semi-perimeter. S is A plus B plus C by 2, because each of the sides is A. The sum of all the sides as the perimeter becomes A plus A by 2, which is 3A by 2. Now S is 3A by 2 and my area of triangle ABC is given by root of S times S minus A into S minus C. As my B and C are A, I can substitute now replaced with root of S into S minus A into S minus A, because my B also is A and my C also is A. Is what we get. Now on further simplification, I get this to be root of 3A by 2 times, I take the LCM of each of the terms. So this becomes 3A minus 2A, which is A by 2 times A by 2 times A by 2 is what I get for each of the terms. Now this on further multiplication gives 3A power 4 by 16. Now this is root 3, root A power 4 is A square and root 16 is 4. So therefore I get this as root 3 by 4 A square. Therefore area of equilateral triangle is always given by the specific formula unit square. Area of equilateral triangle is root 3 by 4 A square unit square. From Heron's formula, equilateral triangle reduces to its area with a special formula root 3 by 4 A square, where A is the side of the triangle, equilateral triangle.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.